Newton's first law using vector notation. So far we've seen forces on diagrams represented by their magnitude, so we've got a 20 Newton force here, and the direction is given by this arrow. Now, because the force here is acting horizontally to the right and it's 20 newtons, I could use component ij form like this and represent it as a 20I Newton force using vector notation. Or I could represent this using column vector notation like this. I've got a component of 20 newtons to the right and nothing vertically. So 20, 0 as a column vector, newtons. So now we're going to look at this notation. So on this particle there are two forces acting. So we have a force in column vector form. So in the x direction we have 4 newtons, and that's to the right, and in the y direction we have 3 newtons, and that's upwards. So 3 newtons in vector notation, or in component ij form, 4i plus 3j newtons. Now we can represent this in a triangle showing our forces. So we have 4i along here, and then plus 3j in this direction, and then the resultant force will be from here to here. And we can work out the magnitude of this resultant force, and we can work out the angle it makes with a certain direction, and so on. Okay, so first example, we've got a particle with these two forces acting on. So what's the resultant force that acts? Again, here's the triangle showing our resultant force, and the magnitude of the resultant force from this right angle triangle using Pythagoras' theorem is 5 newtons. So because there is a resultant force, the particle will accelerate in this direction. Now to work out the bearing of the motion of the particle, so we've got east, we've got north, and they're basically the directions for positive I and positive j. So the bearing will be this angle here, clockwise measured from north. So we need to know what this angle is. Now tan theta is 3/4, so theta is 36.9 degrees, so we need to do 90 minus, so the bearing will be 053.1 degrees. So the particle experiences a resultant force of magnitude 5 newtons, and the direction in which it goes will have a bearing of 053.1 degrees. Okay, in this example, 3 forces act on a particle that's at rest, and the particle will remain at rest. And there's an unknown value q that we need to work out. So this is the first force that acts on the particle, and I'm using component ij form on the left hand side, and on the right hand side I'm using column vector notation. So these are the same. Okay, this is the second force acting on the particle, and q is the unknown that we have to work out, and this is the third force acting on the particle. Okay, so these are identical, and then we add the forces together, and we know the resultant force will be 0 because the particle remains at rest. And then simplifying, and then we solve to get q equals -6. So this will be -6I newtons. For further practice, try these questions.